Hi, my name is Christ Kennedy, and today I'm going to talk to you about my animation editor. So here we're looking at the animation editor spider directory. So because the XML class that stores all your data on your hard drive for your project resources files that are on your hard drive, it expects those files to be at the same place all the time. So the XML file will reference a sprite in a certain directory. And because you might want to come back and change things later, it's probably best if you put all your files in a common directory, as I've done here. Basically, there's just two files. There's the one video file, which is a video that I took holding my camera facing the wall. So it's just 20 seconds or 15 seconds, however long it is, of the wall. Okay, that's the video. And the sprite is the spider sprite, and those are the two resources that are going to be necessary to make this really simple video. So that's where we're going to start. I'm just going to launch the animation editor. So when we launch the editor, it's going to start up with whatever project we had last loaded, and right now it's just a new project. So I'm going to shut off the tooltips. And a basic overview of the editor itself, really quickly. I'll try to summarize really quickly. You have the different components of the scene right now. You have the name of the scene over here, file, dialogue, the scene, whether you want to animate or record or do what you want. Pixies, load the pixies, new pixies. This is a pixie combo box, and this here, when you click on it, moves in forward or back. It appears or disappears. It's the sprite list, the list of sprites that are currently loaded into your project. This here is the sprite draw sequence, because you have to tell it what sequence the sprites are going to be drawn in. This is the frame editor, which allows you to specify exactly for every video frame what this currently selected pixie looks like. Basically, if it's drawn relative to its certain limb, which index of animation, which animation, where it's located, size and angle, that sort of thing. So you determine that specifically for a single frame, for a single selected pixie. And this here, the path editor over here, allows you to add a pixie or change an existing pixie on a series of frames. So the start frame, end frame refer to the video frames. So you have the video of the wall, and you select the start frame 0, say end frame 30, and give it a size start, size end, position start, and you just tell it go, and it adds those frames in sequence along the path that you tell it to, and that's the path editor. And down here we have the timeline. This timeline here is like a storyboard of your video, and you can click on individual frames to see what's going on. So right away what we're going to do is we're going to load the MP4. And now if we remember the hard drive, those files over here that we had in the animation editor, didn't prepare that one right. So here we have the animation editor. This is the directory that we're working in. So the spider, the source video, the MP4, this is the video of the wall, this is the sprite, spider sprite. And now we go over here, we go back here, we say right click on the timeline, and we get a context menu. Then we load MP4. So we load the MP4, and we're going to select that video. So what's going to happen here is the animation editor loads the video, plays the video on a Windows media player, and as the video is playing, it captures an image of your screen. Okay, so it's really important that it does this without being burdened by something else. You can't have your operating system upgrading something, your Windows doing something else, and you cannot have your any other software running at the same time that will slow things down, because this is hardware dependent. It's very important that your hardware be free and unencumbered, and you're not working different things and doing other things at the same time. You can't change the window and pop something up, look at your email or anything while you're doing this, because it's capturing the screen of your computer. So it can't be doing something else at the same time. So you watch the video, let it capture. When the video is done, it comes back to this. So now here we have two timelines. We have the main timeline, that's your working project, and the default timeline, which is just the default name. So we're going to rename this because it's actually the video of the wall source. That's what I call it. So it's the video of the wall source. This here, when you click on these frames, you can look at any one of these frames, zoom in, zoom out. You can select multiple images, and this is actually watching each image as it scrolls by. And what we're going to do here is we're going to select all the frames. We're going to copy all the frames, and we're going to go back to the timeline and paste. Now we have the timeline. This is your actual output project timeline, and I'm going to get rid of this one because we don't need it anymore. So that's all we're going to do with that. So now we have your project video loaded and ready to go. So I'm going to save this. So that's where we're at. Okay, so now that we have this video, we're going to have to create a pixie. So the pixies, the difference between a pixie and a sprite is explained in the article. I'm not going to develop the idea too much right now. Just know that you need to make a pixie. So go over here and click the pixie button, create new, and since the plan is to put a spider walking across the floor, we're going to name this pixie Spider. So now the pixie is created, but it's got a red, this red here is a warning that there's something wrong. Basically, this information here tells you that it's not very bold there, but it's red, and it's telling you that this sprite is not selected. So this is going to be a problem. What you got to do is you got to assign a sprite to the pixie. So the pixie is Spider, and we've decided to load. What we do here is we just we go to the new button, click new, click node in the context menu that pops up, load the Spider pixie. This is a Sprite class file. So for the pixie Spider, I'm going to load the Spider sprite. Now the sprite animation has been loaded into the project, but it's not being assigned to the pixie. So the pixie Spider needs to be assigned the Spider sprite. So we double click on the Spider sprite. Now the Spider sprite is assigned to the Spider pixie. When you click on this button over here, it's not a button, but the frame outside, the outline near the top of the sprite list, this is the list of sprites that are currently loaded in your video project. There's only the one spider. When you click over here, it moves the sprite list behind the sprite draw sequence. And you can click it again to bring it forward anytime you need. So you just click on that, and that pushes it back and brings it forward. So here we're looking at the hard drive again where the Spider video is located. We have the binary source stream and the MP4 and the Sprite class. So what we do here is, at this point here, we have the pixie created, so I'm going to just save the file. So save this as an XML file in the same directory. Spider crawling is the name of the file, and I save it. And then when we go down here, we can double click on the, so we can see here there's an XML file. That's the file I just saved. And the XML file, what it looks like is, it looks like this, okay? So the point of this is, you don't really actually need to know how an XML file works in order to use the animation editor, but what's important to note here is that all the files that this project, the spider crawling project video that the video animator is working on, that you just saved in the XML file, resources its files where they were when you saved, when you loaded them. So like once you've loaded a binary stream, once you loaded that MP4 file and you carried it and you created a binary stream file, that binary stream is now expected to be located in a specific directory. So when you save your project, if the binary stream is not there, then your project is going to fail. The same thing with your sprites. So you have a sprite here. This pixie here is associated with this sprite file name. So this sprite file name has to be there, has to be in that specific directory. You can't change things around and not expect to have any problems. Okay, so now we've got our pixies loaded and ready to go. So we make sure we click on that combo box right there to get everything all settled over here. Be sure to click on the combo box up here because that's usually the reason why something else isn't working. So select the combo, select the pixie over here. Once you have a pixie, what we're going to do is we're going to generate an animation sequence. We're going to make the pixie do something on the screen. We're going to first select which frame. Okay, this frame here, this information is the video frame index. These values here, this value here, the 29 out of 64 is frame 29 of 64. There's 64 frames in the video, and we're going to start with frame 0 for this path, and we're going to use this path to generate animations for the pixie spider up until frame 32. What we can do is use the left side of the button here to take the value from the current frame that we're looking at in the video here and set it into the text box like that, make that the start value, or we can use the right side of the buttons to jump to that frame. So from frame 28 we can jump to frame 60 by clicking over here like that. So what we're going to do is I'm going to set it to 0 and just not using the buttons at all, but using the mouse wheel like that. So this is the way I want it to be. It's going to be frame 0 is the start, frame 32 is the end, and now we're just going to position the mouse jumping to frame 0. Now we're going to use the mouse to position the spider. Okay, so this here is the button for the location to start. This is the start location. 0, 0 is the current default value. End location is at the current default value. So if I click generate frames, it will generate the frames of the spider and it will stay at the top of the screen over here. So we can actually view it, and you can see it's over here. Well, it's being drawn way at the top over there, which is not what we want. So what we're going to do is we're going to take this button and position the spider wherever we want. Here's where we're going to put it. Now, what happens here is we're using the relative to limb. Relative to limb positions the sprite relative to a given limb, depending on the animation frame. Now, all this information relative to limb was decided during the designing of the sprite in the sprite editor. So the sprite editor, when you run the sprite editor and you click draw relative to, the spider, when you animate it, will actually walk across the screen because it'll put one limb down, then move the other limb forward, then its position will move relative to where the other limb is, and then it'll grab that other spot on the floor and keep moving forward. It just moves on the sprite animator. This doesn't currently do that right now. It's good for some animations, but you don't want to move around too much, and we'll get to that later. I'll explain it in the article. So right now it's set to use relative to limb. The limb is the left hind leg, and that's where it looks like when you're doing that. So I'm going to shut that off and draw relative to again. This time without the use relative to limb, it's centered around the mouse. But it's obviously way too big, so we use the mouse wheel to scroll down to 30% of the original value, draw that again, and that's about the size I want it to be when it's over here close to the camera. So that's the wrong angle now. So I'm going to take because it's drawn vertically in the sprite editor, 0 degrees means this particular sprite, because that's the way it was drawn in the editor. At 0 degrees, it's always facing north, but it's just this one sprite that's like this. You can draw your own sprites any way you want. This one was drawn so that it's facing north at 0 degrees. That's just the way it was made. So when we change the value here, and your trig, 50 degrees is counterclockwise from 3 o'clock. So counterclockwise from 3 o'clock, this will put this limb here over here like that. So when we position it, we can see that these limbs are now at 50 degrees. So like it went from 0 being vertical like this, and to now it's pointing this way. So the angle of the sprite here reflects the angle relative to the way the sprite was designed in the sprite editor. So we can change. Now we have to set the final values. This is the start. So we start position, start size, and start angle. We started over here. Now we got the end frame is already set. So when we put the end location, we set it right here, it's way too big. So we want it to be smaller because it's further away from the viewer, from the point of view of the camera. So we make it 15% of the original size, put it over here, all right? And the angle over here, that's right. Okay, so that's about it. This here is a change in angle, which we're not going to change. It's you can change it clockwise, counterclockwise. So the start angle is 50 degrees. There's no change in angle across the 32, 33 frames from 0 to 33. So there's no change in angle. So the final angle is 50 degrees, just like the start. So now when we set the fields here, click the Set Fields button, and all these different options here are being selected because I want the path editor to alter and set the animation, location, angle, size, relative to, and draw sequence. This relative to is set because I want it to use this value. I'm not saying set the draw relative to with this here. I'm saying use the current setting to set it to whatever this is. So use all this information to generate the frames, and nothing's actually done now to the video until you click generate frames. So click generate frames, we go to frame 0, and we can scroll through the animation using the mouse wheel to see where we're going, what's going on. Frame 18, frame 19, 20, and so forth like that until we get to frame 32. Frame 32 is the last frame in the path, so one more frame and the spider disappears. So save your work often. Okay, so now we've got the first path completed, and what we're going to look at is this frame editor. The frame editor is basically the content of what is called the pixie frame. The pixie frame is the information regarding a single pixie for a single frame of your video. Okay, so when we jump around here, this information changes to reflect the content of the pixie frame for the currently selected pixie. So the pixie is spider, and at frame 32 the spider is at this location. That's 15% of its original size. At angle 50 it's doing the animation walking, and it's at frame 2. This is the animation frame, the sprite animation frame 2. Okay, and we can move it around. When I click here, this spider will move because I'm currently looking at frame 32, and I move it all I want. Okay, I can move it back, change this value with the mouse wheel so it'll move further. The mouse wheel, just one click and it goes over there. So it just clicks. You can change it. I can change the angle here like that and do whatever I want. Okay, so we can look at the size too. So you can change for just one frame. So now that's one frame. If I go back, it's back the way it was. The path hasn't altered. We've just altered this one frame. Okay. So now what we're going to do is we're going to go forward one frame. Okay, we go to frame 33 and set this as the start of the next path. So we have the next path is starting from frame 33, which is one more, like we're at frame 33 now. Remember 32 is the last one. So we go to frame 33 is the start. Okay, we're looking at frame 32, but frame 33 is the start of the path. Regardless which frame we're looking at over here, frame 33 is the start of the next path. Frame 64 is the end of the next path. So the information that we're going to affect for this given sprite, the spider, will only be reflected in frames 33 through 64, regardless of what we're doing here. Over here, we can change this value using the frame editor. Okay, and we're just going to leave it like that. I'm not sure. So alright, so now what we're going to do here is we're going to create the second path, which is move the spider from the bottom of the wall to the top of the wall. So the start size is not 30, it's 15, and we're going to set the end frame. So so what we do is we go to follow previous. When we do follow, okay, it was at 30, right? Okay, so we had 30 here, and it was like this. So now what we do is we've got 33 is the next frame, the start of this frame here, but 32 is the previous frame, right? So what we're going to do is, because we're looking at 32, the values of 32 are here in the frame editor. When we click on follow previous here, okay, what that does is it takes all this information here and sets it as the start values. So the start value here is the same as it was over there. No, it's not. Here, use relative to. Don't use the relative to thing, follow the thing. There we go. 570, 374. Okay. And the size is 15. We'll leave it the same size. The angle is 50, but I want to change that. So I'm going to make that 0, or even 10. Well, 0. And then he'll go down clockwise 10 degrees. Maybe a little bit more, like that. Okay. So he starts off, he's size. So did you catch that? So I set frame start 33 and use follow previous. Follow previous means the values from the 32nd frame are set as the start values for the next path. The next path ends at 64. It started at the size 15, which was the end size. The end position is now the start position. Okay. The end angle is now the start angle, or was. It was 50 degrees. And I changed it to 0, and now it's minus 14 degrees over the path. So it starts at 0. So from the next frame on, when I generate it, the next frame, this is frame 33. So when we go to frame 33, when we generate these values for all these different fields, when we generate the values here, it'll be at angle 0, and it'll start at the bottom of the wall, and we're going to move it up to the top of the wall over here. Okay, that's the end position of the spider. So now we're ready to go. Say generate the frames. Okay, we go to the start frame. So scrolling back now, we go forward 39, 30, 31, 32. 32, this is 32 is the last frame of the first path. This is the first frame of the next path. And now we scroll forward because we just added this new path. And the spider is now crawling up the wall. Like that. So we save our project, always a good idea. XML file, and that's that. Okay, so now we have the animation created. So what we can do is we can either select all the frames in the timeline like this, and selecting multiple frames in the timeline will set the animator to cycle around those frames just like this. It's just drawing them all one after another. What happens here is it changes this value here, and then it loads the background video image, and it looks at the pixie frames for that background video image, and then it draws the pixie on the screen where it belongs according to the pixie frame information. So that's when you select multiple frames from the timeline. It just keeps looping around like that. Okay. What you can do alternately is you can go to animate, which just does the same thing. At this point here, you might want to tell it to not draw all the information on the side there. So that'll hide that information. Toggle view, frame, don't draw the timestamp. Okay. So now we've got the scene being animated. But what's going on here is it's drawing everything. It's drawing the background, and it's drawing the sprite, assembling all the limbs, and then it's putting the sprite image resized and turned, and the whole thing takes a lot of calculating, and it slows everything down, and it's not always precise in the timing of the sequence of the frames appearing on the screen, because originally the frames, when they were recorded, they have a timestamp. But if you're taking more time to draw something, and if you got a bunch of different pixies on the screen at the same time, then it's going to take longer, and you're not necessarily going to put the image on the screen in the same time frame that it normally would. So it gets jumpy and choppy, and it's not very good. It's not the best you can do. So alternately, what we have is a way to record all the information. So we generate all the frames, just like the animation, but instead of putting them on the screen on the fly like that, what we do is we store them onto the hard drive along with a timestamp. So to do that, we go to this scene thing and we press record. So clicking record generates all the frames. And it doesn't matter if it's choppy here, because this is the point. It's choppy here all at once because it generates all the frames that it needs to generate, and it puts them onto the hard drive. And now we have a file on the hard drive that has all the information that we need. And that is the record file. So we have the original MP4. We have the binary stream. So we know the MP4 is a lot more compact. The difference between this binary stream and the recording binary stream is that the source binary stream keeps track of the time frame, where the timestamp between each frame is the distance, the time between each frame, and not the time from the beginning of the video to that one frame. So there's accumulated error when you're adding up all the different frames, because it might be off by a few microseconds or whatever. Even if you did have enough time to put the image on the screen and draw everything and put it on the screen, the accumulation of time errors for all the frames will be such that the animated video will be longer than the source video, because you've accumulated all these errors. They're errors measured from the end of one frame's image to the beginning of the next frame image. That's the timestamp in the original binary stream. The reason that is you can shuffle them around and edit the video all you want, and it will still be the same video. Basically, it'd be the same length when you record it. But the recording is the accumulated time of all the frames is used as a timestamp for each frame. So each frame then, if they're played in the original sequence, will play at exactly the same time that it was recorded in. So that's more accurate in terms of choppiness and making it look better. So now that we have a recording, we can go to the scene. Before we only had animate and record. Now we have playback and playback set speed. So when we play back the recording, and presumably this is much smoother. You probably can't tell because it's a really simple animation. But when you have a lot of sprites being drawn at the same time, and it's more difficult, some images are bigger than others, it's not as good, it's not as choppy unless you have the recording. So that is the recording. Now what you can do is to record live action actors on the screen moving around. Their motion will be even more choppy if you have fewer frames to work with. So what you can do is you use a third-party video editor, use the original source video of your live actors, you keep an audio recording of that video, and then you make an other video that's twice as long or 3 times as long, depending on your hardware, what your computer can manage. And you make a video that's half the speed, let's say. So half the speed, it's twice as long. When you convert the MP4 that's twice as long into a binary stream of captured video images, presumably it'll capture twice as many images as it would normally on the normal speed, because it's twice as long, half the speed. Then what you do is, when you've animated your video at half speed, you want to create a video that you can watch at regular speed, so you speed it up by changing the timestamps in your recording. So now the recorded video, when you play it, is twice as fast. So if you have a really good computer, you can get away with 4 times the speed, get better quality video, and you could just improve your the output there. Because live action videos, it's one thing to animate a character like a comic character or a cartoon or the spider or a sprite or any kind of sprite on a still frame, but it's quite another when you have live actors in the background and they're moving around and you're dropping frames left and right. It's really just it's poor quality. So if you record your source video to live actors and then you expand the speed, you get the idea. So anyway, that's the animation editor, and well, lots of fun. You should read the article and leave me a message, and thanks.